All right, good morning, everybody. Um, so, we're going to start a new section. This is chapter 3 where we're at. We skipped over chapter 2. There's some proofs in there. We're not quite going to do proofs yet. We might do some of it, but we're going to get some when we start a new section, a new chapter. There's going to be vocab. And going forward, there's going to be a little difference on how I have you do this. After I present this is going to be presented through Delta Math, so you must watch it, and I'll know if you watched it. And two, you're going to have to rewrite these definitions out on a piece of paper for your notes. Anyway, let's get right to it. First one, parallel lines. Two or more coplanar lines that never intersect. Should know what coplanar is. That was vocab from the last section. So parallel lines will never intersect each other. They are marked. Everything we do in geometry gets marked, right? So we have markings right here. I don't know if there's a laser pointer. It'd be nice. I'm not going to look for it now. So we have markings. This is how you mark two parallel lines. If you have two different parallel lines, you would put two of these. So this means parallel. The words here, because of the markings, is line L is parallel to line M. Line L, line M. We can name a line with lowercase letters at the ends. The symbol for parallel is a double slash. L is parallel to M. These are the same words. This is the symbols for these words. These are the markings that give us these symbols. So that's parallel lines. Perpendicular lines. Two lines that intersect and form a right angle. Two lines that intersect and form a right angle. Line L and line M intersect right here. Call it point P. They intersect at P. What we say is that line L is perpendicular to line M. Why? From this little symbol here. This symbol means you have a right angle. This symbol means perpendicular. I wonder if I can copy that from the last page and put it in there. Let's see. Let's just see if I can do that. Copy and paste. Well, I got that part. So let's go back to there, there. There we go. All right. I'm going to save that. Good. So perpendicular, that's how you mark things perpendicular. They're marked with that little box in the corner. Means you have a right angle. Line L is perpendicular to line M. The symbol is this upside down T. Line L is perpendicular to line M. These are the words that go with the symbology. Mathematics is all about symbols and being able to say those words symbolically. So we have a couple postulates here. Postulate, remember, postulate is a statement accepted as true without proof. The parallel postulate, I like these two postulates. Parallel postulate. If there is a line and a point not on the line, then there is exactly one line through the point parallel to the given line. There is exactly one line through P parallel to L. So there's only one way we can draw a line that goes through P that would be parallel to L. Same thing goes with perpendicular. If you're given a point and a line, there is exactly one line through that point perpendicular to the given line. So these are important. What does that look like? Well, there we have a point P and a line L. How many ways, all this is saying is how many ways can I draw a line through P that would be parallel to L? And there is, let's go orangey. And there is only one way to do that. And I'll do that and then just move it a little so it goes through P. There we go. So there is the only way to draw a line through P parallel to M. So now we know that those are parallel. Mark them, right? If I had some second line, I don't know, second line through P. Well, look, it would intersect line L, which means it could not be parallel because the definition of parallel are two coplanar lines that never intersect. So all that postulate says is there's only one way to do this. Same thing goes with perpendicular. There's point P. Well, it won't let me keep it. All right, I have to do it all over again. Point P, double arrow, and let's go back to orange. All right. There is only one way to draw a line through point P so that it is perpendicular to line L. So if I have line M here, there's only one way that this goes through, perpendicular. Right? So again, if I drew some other line through P, it may intersect, but we definitely do not have a right angle at this spot. So those are those two postulates. A transversal. The definition of a transversal is a line or a line segment that intersects two or more given lines. Here we have line L and line M. They are not parallel. We're going to be talking about that tomorrow. What happens when a transversal intersects parallel lines? But I just want you to get the idea of what a transversal is. It's a line or a line segment that intersects two or more given lines. Here, line T intersects line L and line M. So T is a transversal to line L and line M. When a transversal intersects two given lines, 8 different angles are formed. Pairs of these angles have specific names and relationships. Here we have L. Let's see if I can change this somehow, unless I have it. Nope, I have it all together. Whatever. Here we have the same diagram as before. Line L and M intersected by transversal T. Notice how many angles are formed here. I have 1, 2, 3, 4, 5, 6, 7, 8. I'm going to try to be consistent in naming them that way with those numbers. Excuse me. In those positions. But we have 8 different angles formed when this situation happens. What are those relationships? Well, the first one is called corresponding angles. Corresponding, 2 angles that lie on the same side of the transversal and the same side of the 2 given lines. Look at angle 1 and angle 5 here. Angle 1 is on the left side of the transversal. Angle 5 is on the left side of the transversal. Angle 1 is above line L. Angle 5 is above line M. So angle 1 and angle 5 are corresponding angles. They correspond to the same position in the diagram. Alternate interior angles. 2 angles that lie on the opposite sides of the transversal and between the given lines. This is important. Alternate interior angles. Alternate means to go back and forth. Interior means inside. So look at angle 3 and angle 6. Angle 3 and angle 6 are on opposite sides of the transversal, right? One's on this side and one's on this side, and they're inside of the two given lines. Both sides of the transversal inside of the two given lines. Alternate interior angles. That means we might have alternate exterior angles. Alternate exterior angles. Well, let me go back there for a second. Right? It's not just 3 and 6. If there was an angle over here and over here, those are also alternate interior angles. So that would be 3 and 4 and 5. If we were looking at it, just like over here, corresponding 1 and 5, 2 and 6, etc. We'll look at a bigger diagram later. Alternate exterior angles. Two angles that lie on opposite sides of the transversal and outside of the given lines. Well, here we have angle 1 and angle 8. They're on opposite sides of line T. One is on the left, one is on the right. Angle 1 is above line L. Angle M is below line M. So they're outside. This is interior, right? This is inside. Out here is outside, exterior. Alternate, the alternate sides of T, exterior, outside. Consecutive, same side, interior angles. Consecutive means one after the other. So they're on the same side. Now, the book uses consecutive. I think same side is more descriptive, right? They don't use that term, but I use that term. I like it because it describes, just like I have alternate, now I have same side. So they're on the same side of the transversal inside the two given lines. Look at angle 3 and angle 5. Same side of T inside of L and M. That makes them same side interior angles. Same side exterior angles. Same side of the transversal. They're both on the left side of T, outside of the two given lines. Outside of the two given lines. 1 and 7 are alternate. Same side exterior angles. Same side of the transversal, outside of the two given lines. 1 and 7 are on the left of the transversal. They're both not on the interior of the two given lines. And there's a little diagram of that comes from your textbook. Same things that I was talking about. So just an idea here so that we can have them look at this diagram. This diagram is turned a little than what we're used to. But if you have two lines, here we have two lines, line 1, line 2, call it line L, and line M, horrible M, but whatever. And here's our transversal T. Which pairs of angles would be corresponding? Well, corresponding means they have to be in the same position. Same side of the transversal, same side of the given lines. So 1 and 5. Color do I want? Let's use blue. 1 and 5 are one pair of corresponding. So identify all of them. 2 and 6. 2 and 6 are on the same side of the transversal to the right of the given lines. 3 and 7, 4 and 8. Alternate interior angles. Where are those? Well, 2 and 7. Alternate sides of the transversal inside the two given lines. Another pair, 4 and 5. Opposite sides of the transversal inside the two given lines. So there's two pairs of each of these. Alternate exterior. Alternate exterior. Let me get rid of that ink. It'll get confusing. All right. Alternate exterior. Opposite sides of the transversal. So we've got angle 1. Start there. Now I know I have to be on this side of the transversal, outside of the given lines. So that will be 1 and 8. What else? All right, let's start at 3. If I was at 3, now I have to look at all the angles on this side of the transversal, but outside of the two given lines, alternate exterior angles. Consecutive interior. Consecutive interior. One after the other on the inside. That would be angle 2 is on the top of the transversal. Angle 5 is on the top of the transversal. They're both inside the two given lines, so these are consecutive interior. Another pair of consecutive interior would be 4 and 7. Same side of the transversal, inside the two given lines. Now I didn't have consecutive exterior. Let's see if I can put that in. D, E. Consecutive exterior. And save that so it stays there. So consecutive exterior angles. Clear the ink. Exterior, outside, one after the other, same side of the transversal. So in that case, I'm like tired of those colors. Here we go. Let's go for purple. Consecutive exterior. This one's outside, outside, same side of the transversal, outside of the two given lines. 3 and 8. Same side of the transversal, outside of the two lines. Classify the pair of numbered angles. What relationship does 1 and 5 have? 1 and 5. Here's going to make this easier. I'm going to just Control C. Copy that for this page. Paste. So, whoop. So, each of these are going to be either A, B, C, D, or E. Number 3, which of these are these? Well, these are on the same side of the transversal, same side of the two parallel lines. So these would be corresponding angles. This is A. Horrible writing. How about number 4? What relationship does 2 and 7 have? I examined where they are. Well, they're on opposite sides of the transversal, outside of the two lines, so they alternate exterior. This would be C. And number 5, 5 and 4. Well, they're on opposite sides of the transversal, so they alternate inside of the two lines. They are alternate interior. This would be B. All right, so your homework tonight is to fill in the definitions on the worksheet attached to the Google Classroom and submit it there. There's a worksheet. It says vocab and notes. Please note I have added to materials for this section a set of flashcards and a chapter summary. Chapter summary will be for when we're done, but it's kind of something good to look at, 1 or 2 pages that kind of summarizes what we've done. Not everything will be on every chapter summary that we've done, but most of it will be there. So take a look at that. All right, that's it for now. Let me see how to stop this. I think it's right here. Yes, it is. All right, have a great day.